Hello, so continuing on this weekly contest 331, the second problem, which is count vowel strings in ranges. So basically here we have an array of strings of words, and we have a 2D array that contains a list of queries, right? And each query has a left and a right side, of course, right? It's a range. And the problem asks us to find the number of strings in that range that start and end with a vowel, right? And of course the vowels are just these, right? Yeah. And the goal is for each query to return the number, right? And we return that the number of strings that have this definition, and we want to return an array with the answer for each query, right? So that's sort of the problem. Now, so if we take a look, for example, here, from 0 to 2, right? From here to here, there are only 2 that have a start and end with a vowel. So we put 2 from 1 to 4. So from here to 2, 3, 4 to here, there is this one, and this one. So there are 3. From 1 to 1, so only 1. So only this position here. This 0, because this doesn't start and end with a vowel. So this is the answer array, right? So you get the idea. Now, if we look at constraints here, we have the number of words can be up to 10 to the power of 5, right? And the number of queries also 10 to the power of 5. So already looking at this, you know that an O of n, with n being the number of words, and O of q being the number of queries, O of n by q would not work, right? Because we would get 10 to the power of 10. So we definitely can't do something like a brute force solution. So let's think about a more sophisticated one. Okay, so how do we solve this? So let's see here. So for example, the idea of what we are looking for is a way to not have to do for each query, go through all the words and do it, right? And you can see here there is sort of, let's sort of map this to something else, right? Just to think about it better. So let's say you have a list of numbers, right? 3, 4, 5, 6, maybe 8, 9. I'm just doing a set of numbers, and let's say you have the exact same queries, right? But let's say the question asks us to find the number of even, right, numbers in that range. So pretty similar, right? There is basically a condition, and we want to find the number of elements that fit that condition in a range, right? So if you have that, what would you do? Well, generally, like similarly, like with these problems on ranges, what we go to first is prefix sums, right? But usually prefix sums is we add the values themselves. So 4, 5, let's say you want a range that has a sum smaller than some value k, right? In that case, what you will do is you say, okay, let's take the prefix sum. So basically each field, right? Prefix I would be the sum from 0 up to I, right? So here that would be 3, 6, 10, 15, and then 21, right? And then to find the range, you will just check, for example, to find the sum for this range, right? Let's say one of the queries is 0, 1, 2, 3, is 2 to 3. Then you will just take the prefix of at 3 minus the prefix at just before the start of this range, which is at 1, 2 minus 1. And that will give you basically 10 minus 3. And that will give you how much? That will give you 7. And 7 is exactly the sum of 4 and 3. So this is how we usually do operations in prefixes on a list or on an array, is to always think about prefix sum when you have a range and you want to do some calculation, some accumulative calculation. Okay, so that's the first step. Okay, so now we let's try to map it to the numbers first, and then from there try to map it to the words. So if we want to map it to the numbers, then what we can do is we can say, let's just, for every odd number, let's create a prefix sum for how many odd numbers are up to I. So prefix of I, sorry, even numbers. So prefix of I would be count of even numbers from 0 to I. Positions, of course, right? So to do that, well, let's add the positions 2, 3, 4, 5, 6, 7. So is 1 odd? No. Is 1 even? Sorry, I keep saying odd. Is 1 even? No. So we put 0. Is 2 even? Yes. So we have 0 plus 1 gives us 1. We go to 3. Is 3 even? No. So we still have 1 from the prefix I minus 1. So basically, prefix of I would be equal to prefix of I minus 1 plus basically 1 if the element at I is even, otherwise plus 0, right? So we go here, 4 is even, so we add 1 to the prefix I minus 1. We go here, 5 is odd, so we just put 2. We go here, 6 is even, so 3. We go here, 8 is even, so we have 4. We go here, 9 is odd, we have 4, right? And now if we look at the range 0 to 2, so 0 to 2, 0, 1, 2, 3, 4, 5, 6, 7. So to find how many odds are in the range 0 to 2, well, we just take the same thing we did with prefix sum. We just take the prefix of I minus the prefix, of the right position minus the prefix of the left position minus 1, right? Because when you want for a range, right, LR, we already said that to get this range, you need to go to the previous one and subtract it from the prefix at R, right? And so we just take the prefix at R minus the one before, which is L minus 1, and that will give us the number of even in this range, in the same way we have with prefix sum, okay? So this here means that to find for the query, what we need to do, so this would be the answer for query. It would be, okay, how many are in the range 0 to 2? So 0 to 2 is just here to here. Okay, so previously we can assume that before this 0 value, that there was 0. So for prefix, if it's equal, if left is 0, then we don't need to subtract anything from the before because there is nothing, right? And so here we can just say 1, okay? Because that's just prefix of R minus nothing because we don't have it, okay? And now for 1 to 4, 1 to 4 is from here to here, right? So what's the prefix sum here? Well, it's prefix of R, which is 2, minus the one before, which is 0, so we have 2. What's the answer for now? What's the answer for, so this was, I think, 2 here, right? Because of 4, 2, yeah. So what's the answer for 1, 1? Well, 1, 1 is just this position here. And so it's just prefix of R, which is 1, minus prefix of 0, which is 0. So it's 1 minus 0. So we have 1, and this is the final answer, right? So that's the idea of how usually we apply prefix for sums, but you can even apply it for just queries for ranges by just pre-calculating it, right? For pre-calculating prefix of I, and then from there it's easy to find it for the range, right? And if you take a look here, this is actually the right answer, because between 1 and 4, for example, how many even we have? We have 2 and we have 4, and that's exactly 2, okay? So now what's left is just to apply it to this problem that we have here. So let's do that. Let me just get rid of this portion here. Okay, so how do we do it for words? Well, for words, let's just have the prefix then. So what do we need our prefix to be? Well, how many is ABA? First, just to not have to say every time word starts with a vowel and end with a vowel, I'll just say that we say that a word is valid if it starts with vowel and end with that vowel. So that way, with this definition, I don't have to each time say the entire thing. I can just say the word is valid, okay? So is ABA valid? Yes, it is. So we can just say we have one valid starting ending at position 0, right? Now we take a look at BCB. It's not valid, so we just do prefix I minus 1, the same thing we did previously for the numbers, and we add, so it's just 1 because this one is 0. ECE, is this valid? Yes. So we take prefix of I minus 1 plus this value 1, so we have 2. Is this one valid? Yes, it is. And so we just say 2 plus 1, 3. Is this one valid? E, yes. So 4. Okay, so now to find for the queries, what do we need to do? So the answer is going to be, let's do it. So the answer first we do, let's take a look at this. So we have, let's actually add the indices. I think that will make it easier. 1, 2, 3, 4. So first, the range we are looking for is from 0 to 2. So that's this range here. And since it starts from 0, we can just take prefix of 2. What is prefix of 2? 0, 1, 2, 3, 4. Prefix of 2 is just 2. So the answer is 2. Okay. And then now for the second part, which is 1 to 4. 1 to 4. So that's all the way here. So what did we say? It's prefix of R. Let's actually write it. So it's P of R minus P of L minus 1, just the one before the start of the range. So that means here it's 4 minus the start of the range, which is this value 1, so it's 3. So here we put 3. Okay. Okay, let's go to the next query. So the next query is for 1, 1. So it's just this one. So it's just prefix of the right place, which is prefix of 1, minus prefix of L minus 1, which is 0. So this is just 1 minus 1, so it's 0. And this is, if you take a look, this is the right answer because this one is not valid, so it's 0. Okay, and this is the final answer, right? And that's pretty much it. So we can use this prefix idea, and from there, once we do that pre-computation, we can just do something that is linear in terms of the number of queries, and that's exactly what I did here. Yeah, so I hope that was clear. Let's implement it and make sure it passes test cases. Okay, so let's implement this solution. So first we need, of course, to just define the vowels, right? So those are just, as the problem says, it's just these 5 ones. And then we need our prefix array, right? So it's going to be just initialized with 0. It's going to be for every word, right? So for every index, so we just need to define n as well. It's the length of words. Okay. And then we need to go through the words, right? So this is the word in enumerate for words. And what we want is basically we want prefix of I to be equal to prefix of the previous one, right? Plus 1 if this word is valid or not, right? And so let's say plus 1 if is valid. Okay, if W is valid. Otherwise, it's going to be just this, right? And so we can just say otherwise it's just plus 0, right? Now the problem is, what if this I minus 1 is what if it's I equal to 0? Then this is a problem, right? So what we can do here is just say maybe the previous is equal to this. If I is bigger than 0, else just put 0, right? So that's what we have here. And now we need to define is valid here. So let's just define it. So what is valid for a word? Well, it just needs to start and end with a vowel. So W of 0 needs to be in the vowels, and the last one needs to be in vowels as well. And we want to return that. Okay. And now we can just have our result array for the queries and go for the queries. Because we have the prefix, we can calculate for a range now. So we do in queries. And remember, if L is bigger than 0, then we have a left side that we can subtract from. But if L is equal to 0, then we want to do something special. But let's focus first on L bigger than 0. Then, well, in the range, it's just the prefix at the ending position minus the one just before the left position. So that's L minus 1. And this is what we want to set for this query. But if it's like start at 0, then we can just take the entire prefix R, because that's literally the definition of prefix of R. And so we can just say append prefix of R, right? And then we'll return res. You can, of course, like get rid of all of these if and else conditions by having this starts with just a dummy 0 value to avoid these checks. Yeah, feel free to try that. Let's submit this. And this passes, right? So you can see this is a new concept of usage of prefix that I want you to make sure you understand, and you can apply in future problems, right? In terms of time complexity, we have here, which is O of Q. Let's say Q is the length of queries. And then we have this here, which is the number of words, so the length of N. And then, so this is overall time. So you can see here, the overall time is just O of N plus Q. And then in terms of space, so this should be fine, 10 to the power of 5 roughly. And then in terms of space, we are using this extra prefix array that is O of N. So this is time, and then we have O of N space. Okay. Yeah, so that's pretty much it, I think, for this problem. Please like and subscribe, and see you on the next one. Bye.